Okay, so in the second video we're going to be doing more of you try these problems, but first I'm going to explain this one. If I have a square that has 225 meters squared as its area, I need to find the length of one side, the perimeter, and the length of the square's diagonal. If I want to go about doing this, the first thing I have to remember is that the area of a square is equal to 225 meters squared, and the formula for the area of a square is A equals the side length squared. Now, so that means that 225 meters squared is going to equal s squared. And to find s, I have to take the square root of both sides. Therefore, s equals 15 meters because I know that my perfect squares. So the first part, what is the length of the side, is 15 meters. Next, what I need to do is figure out the perimeter. So perimeter of a square is really just 4 times the side length, or 4 times 15, which would be 60. So we know the perimeter here is going to be 60 meters. And remember, perimeter, because we're dealing with 2 dimensions still, I don't have to worry about meters squared. It's just going to be meters. So now let's look at the diagonal and how we would figure that out. So to find the diagonal, I have to first label these sides. So these are both 15 meters. And the diagonal here will either be there, or if you wanted to, for whatever reason, you could do it the other from that vertex to that vertex, but then you need to know that that was 15 meters. It doesn't matter how you do it as long as you do it. So the diagonal is my c, or my hypotenuse. So it would be 15 squared plus 15 squared equals c squared. If we notice something here, we notice that this is going to be an isosceles triangle. And if it is an isosceles triangle, that means, and any time you're dealing with a square, it will be, that means that these side lengths will be the exact same. And here I could realize I can factor 15 squared out from both of them. So this is really 15 squared times 1 plus 1. And again, if you know what I'm talking about here, if I just distribute the 15 squared, then that would give me 15 squared plus 15 squared again. But I don't want to do that, and you'll see why. So this really means that I have 15 squared, let me erase that real quick. I have 15 squared times 2 equals c squared. To get c by itself, I take the square root. So taking the square root of 15 squared is just going to be 15. But the square root of 2, I can't simplify that down. And that would mean that my side length would be 15 square roots of 2. And this will actually work with any isosceles triangle. For example, say I didn't know that, say it wasn't 15 and 15, if it were 7 and 7. If I wanted to find the hypotenuse, it would be 7 squared plus 7 squared equals c squared, or 49 plus 49 equals c squared, so 98 equals c squared. Then when I'm taking the square root of both sides, I know that my largest perfect square that divides that is 49. So it would be the square root of 49 times the square root of 2, or just 7 square roots of 2. So c would equal 7 square roots of 2 units squared. And that works for any isosceles triangle. So where you have a is equal to b, so if they're both a's, then c is going to equal a square roots of 2. So a squared plus a squared has to equal the quantity a square roots of 2 squared, because if I square both of those, that's really just saying a squared plus a squared equals 2a squared, which is true. We know that's true. And that's why anytime you're dealing with an isosceles right triangle, the hypotenuse is going to be the length of the side times the square root of 2. So use that shortcut to solve these following problems. Pause the video here and try this problem. I know we're getting crazy with these pictures. And when you're done, come back and you'll see the answers. Okay, so you should have gotten that the answer is 100 square roots of 2. And obviously you weren't a scrub like me, you actually put feet there. But that's how long it was. If you don't know how to do that, essentially what we're saying is each one of these side lengths is 100, if I could draw, 100 feet, which means that this would be my hypotenuse. So I'd have 100 by 100. And if you want to do it the long way to figure out what c squared is, you'd have to do 100 squared plus 100 squared, which is really 10,000 plus 10,000. That's 1,000. 10,000 or 20,000 equals c squared, and then take the square root, which would just be square root of 10,000 times square root of 2, which is just 100 squared to 2. If you know that that relationship exists from the very beginning, all we have to do is take the side length and multiply it by the square root of 2. So obviously, this would be much, much quicker. If you were trying to solve a problem like that, all you would have to say for your work is isosceles right triangle, hypotenuse equals square root of 2 times the side length. So there you go. Let's try another one. Find the area and the length of the diagonal. Pause the video here, and when you're done, come back to see the answer. Okay, ready to have your mind blown? The answer was here whole time. Diagonal length is 9 squared to 6. The area is 243 units squared. If you got that right, move on. If not, stick around. That's a circle. I need a square. Square, square. Nope, another circle. I'll get it. I'll get it eventually. Hold on. Alright, square. So we were told the side lengths were 9 square roots of 3. So that means the diagonal, the hypotenuse there, has to be 9 times square root of 3 times the square root of 2, because that's an isosceles right triangle. So square root of 2 times square root of 3 equals the square root of 6. So it would be 9 square roots of 6 units. What is the area, it asks? Well, the area would be 9 square roots of 3 squared, because we're talking about square, which would be 81 times the square root of 3 squared, or 81 times 3, which is 243 units squared. Conversely, if we gave you the hypotenuse, you could actually find the side length if you know it's an isosceles right triangle. So say I said that the side length, so I said if C were equal to, say, 12, and if it's an isosceles, if that's the diagonal of the square, or it's an isosceles right triangle, and that's the hypotenuse, you would say, well, then the side length has to be 12 divided by the square root of 2, which simplifies down to 12 square roots of 2 over 2, or 6 square roots of 2. Fun fact, in case we ask you, hint, take notes. Let us move on. One last one. This time we're dealing with a cat in the tree. Try to figure out if the ladder will reach. When you're done, get back here and check the answer. But right now, pause the video. So the answer is yes. You would be able to get the cat from the tree, but stick around for this explanation because I want to explain why it would be that way. We're told that our triangle has a base length from the tree is 10 feet, and the height is 22 feet. If I want to figure out what the minimum hypotenuse is, I just have to take 22 squared plus 10 squared, and say that's equal to c squared. Well, we know 22 squared is 484 plus 100 equals c squared, or 584 equals c squared. And really all we need to do is get an approximation here. So we're going to take the square root of 584, which is 24.17 if we're rounding to the nearest hundredth there. But that's just kind of the bare minimum. In fact, we have that c just has to be greater than or equal to that, and we know it needs to be, well, that's kind of our bare minimum. It has to be less than, obviously, 32 feet. Otherwise, that would be too long. But as long as it's longer than 24.17 feet, we're good. So 25 feet would work. we would be able to save the cat even though it's grumpy. That's okay. Maybe if you save it, it'd be happy. Probably not. It'd still hate you and the world. But let's move on to Pythagorean triples. Now, Pythagorean triples are a very special case. And we know that these work for any triangle. And these are kind of just some of the bases, right? So, not the sum of the bases, but some of the base Pythagorean triples. So we know any right triangle will work with legs 3 and 4 and a hypotenuse of 5. We also have it with 5, 12, and 13. And lastly with 8, 15, and 17. And they keep going on, right? I just listed 4. There are tons. And in fact, kind of off of these base ones, we can do something. If you know that one of them is a triple, then all I have to do if I want to figure out another set of triple is multiply it by either 2 or 3. So say I had 3, 4, and 5. If I want to find the next triple, I could multiply them by 2. So we know conversely that 6, 8, and 10 would also work, right? 6 squared is 36, plus 8 squared is 64. That will equal 100. We can even do this with other factors. We can do this with, instead of multiplying by 2, let's multiply by 3. So 9, 12, and 15 will also work, right? 81 plus 141 will equal 225. And these are just some of the base things we can figure out very quickly if we know these Pythagorean triples. So have these memorized, guys. It's going to save you a lot of time. You can know instantly that if you ever see 3, 4, 5, or 6, 8, 10, or 9, 12, 15. Heck, if you even want 12, 16, and 20, right? These all work. And you can do it with any of these 4 as well, but I'm just kind of showing you the 3, 4, 5 because that's kind of the most common. So have those memorized and try out the problems ahead. If you have any questions, make sure to raise your hand. And as always, take fantastic notes. Have a good day now. Bye-bye.